Now that's the big story, right? If you're an SME, you want to improve. That's going to cost a lot of money, and no, it's not interesting. But I want to tell you that building a basic simulation model is possible. If you look at your manufacturing process, you don't have to build everything into the industrial metaverse. Choose the right use case and the part which is going to give you the maximum benefit, and you can just build on that basic simulation model. I'm going to talk a little bit about that system called a build basic simulation model, but I'd like to bring also your attention to the virtual commissioning on the bottom left-hand corner, because this is something that I was personally involved in with a use case, which I do one use case where we had a manufacturer in China, the end customer in Dubai, and our engineering team in Germany. And by having this digital twin, what you would normally do without a digital twin is to have a factory acceptance test in China. Everybody flies down with all the stress that you have on site, and you do the factory acceptance test. With this, we did the factory acceptance test before the machine was erected, and we did it in the comfort of our office. You can drink a coffee, you can sit on a table, you can do a factory acceptance test, because we had a digital twin. And what happened, you have a punch list of items during a factory acceptance test. 20, 30 list of things which the customer wants to improve. There are software errors, there are software bugs, there are things that you need to optimize. Conventionally, it would have taken us about 2.5 to 3 weeks from China to Germany and end up in Dubai to get all these things solved. With this digital twin, we did it in 3 days because we had it running in the office. The commissioning engineer, the design engineer, and the project manager just went from each other's table and solved the problem. And they did save so much time compared to doing this on site. Now, if you look at building the basic simulation model, unfortunately or fortunately, we have many nice references, but without customer consent, I can't show it to you. But here is one based on our own solution, which is called the integration of the COMOS, ECS7 and CMIT. So ECS7 is the control automation which is running on the factory shop floor. COMOS is your engineering planning tool, and CMIT is the Siemens simulation tool, which is simulating IOs, input-output units. They may sound very simple, but in a complicated factory environment, you can have up to maybe 10,000 IOs and hundreds of thousands or millions of data points. And here in this video, you will see that with these 3 steps integrated together, you can build very quickly a digital twin. A basic simulation model looking at only your input-output units. So there are standard libraries in the control module, which you can pick and drop. And you can create this signal creation to connect with your ECS7 system. You can look into a process planning. In this case, we're looking at a stirred tank reactor. You can import this into your actual automation code. So you don't have to create something else. You use the automation code that is running on your shop floor, the same program that's running on your shop floor. You visualize the stirred tank reactor, and then you can simulate and validate all the input-output signals in the PC on your table without going onto the shop floor. You can change the signals, you can try different signals, you can do everything. Sky's the limit. And all at the comfort of your desk with your computer. And by doing this, you're really saving the time of prototyping. You can optimize without making mistakes. You don't have to worry about making mistakes because it's a simulation, it's a digital twin. So you can be creative and do various things and optimize your shop floor. So a lot of things goes into variation orders. I think if those of you running a manufacturing plant, you will think of vendor lock-in variation orders, that's going to kill you, right? But here, if you, every engineer offered trained on this platform, you can do this by yourself. And you have libraries here which have simulated all key equipment, variable frequency controllers, motors, contactors, circuit breakers, programmable logic control, input-output modules, network equipment. And it's not limited to Siemens, you can integrate also third-party equipment inside here. So you can bring in third-party components if you have it on the shop floor, and you can bring it all in one tool. The customer experience or reference which I'm allowed to talk about is this one, which I quite like. It's from the company Escatec in Penang. It's a global company, and they used our Siemens Velo process preparation for their PCB circuit board development. And they reduced their respin time, which normally takes 6 to 8 weeks, just to 1 day. What took them 6 to 8 weeks, they reduced it to 1 day, because they could do everything in the digital twin of this process and not go through the iteration cycle of design, prototype, and redesign, and keep doing this again and again. So this really brought them a lot of benefit, and you can imagine the time saved here on a new product introduction. If you're doing it on a big scale, you're doing a large volume, you probably, it doesn't matter much. But if you're doing low volume NPIs happening very frequently, then you don't want to have this respin taking up so much of your time. And this is one of the really big benefits that the customer saw from this. So now looking back at the complete manufacturing processes, so far you looked at the shop floor and creating a digital twin of your machine or your plant and so on. But think about the next step of digitalization and with the problem of getting skilled operators. Today there's an issue with a lot of manufacturers to get a skilled operator. So how are you going to train the skilled operators? If you go the traditional method, you need to have a machine, you need to have an extra machine just parked for training, or you use your existing machines for training. But once you have this digital asset, you can build your virtual training simulator. And how does that work? First, you do an assessment of what you want to train, and you go into this creation tool, and then you do the virtual training, which I will show you in a little bit how it looks like. And by doing this, you can reduce your training time by up to 50%, and you can increase your quality to a standard workflow by up to 40%. So what can be done here is that the operator who is trained, he doesn't have to worry about making mistakes. He can just go ahead because it's a virtual training simulator. Imagine if you're working on if you're manufacturing from an automotive industry and you're manufacturing parts of an engine, you want to train your personnel to fit parts into an engine. And if you do this virtually, there's no issue. If you do it on a real engine, you need to have the engine, you need to have the parts, you need to physically go and make those installments or those modifications. And if you're going to train many operators, you need many of those prototypes. But with a virtual system, you just need your virtual training classes, or you need a PC with a screen, and you can train as many operators as you want. You can train them 24/7, and that's much more productive. So how does the system itself work? You see whatever digital assets that you already have, and which you would have had from the design and the manufacturing phase. You have your 3D CAD data, and you have your instructions of these different products that you want to produce. You just bring them into this creator tool, which is called Virtual Training Simulator, and it generates the versions for the trainer and the instructor. And the trainer can be either in a desktop version or even in an augmented reality 3D glasses version. And once you have the model running, this is fully SCORM compliant. So you can generate a lot of e-learning, but is it SCORM compliant? So this system provides a SCORM compliant e-learning software and together with the learning management statistics. So you want to know, did my operator do level 1, level 2, level 3? How did he perform in level 1? How did he perform in a certain task? Is he making mistakes repetitively in a specific task? For example, with the engine, does he make a mistake always by changing the fuel injector? Then you know, how should I train him better specifically for that task? So these learning management statistics will be there, all provided through the system. And you have this log and you can report this to your management. This platform is, once you have it, you can use it and you can create those virtual trainings yourself. You don't need to depend on Siemens, right? So you can do this by yourself as long as you're trained with it. You have data from a vendor and you can feed it in and make your own virtual training solutions. So that's reducing your training time by up to 50%. It's making it higher availability and flexibility. If tomorrow you have a different product which you are producing in what I spoke about just now, if you are doing a low volume, high variant production, then you have different products all the time. So this is going to give you the full flexibility to do that. You can improve your employee safety and motivation. I mean, it's so much more cool to work with the virtual reality glass compared to the traditional, right? And in terms of safety, you don't have to worry about mistakes because you're not physically doing it. And what is most important for the operator is just the process, it's just the step, right? It's what he's doing with his hand will eventually come. You reduce your prototypes by up to 50%, you save a lot of time and money by that. You reduce manual mistakes by up to 40%. And you reduce your downtime costs and you make it high availability. The beauty with the digital twin is if there's a problem, you restart the system. Maybe change the computer, you change your screen. But if there's a problem with the actual prototype, you need to remanufacture that complete unit again. So this is really not very flexible and increases your cost. So in conclusion, the digital twin is key to maximize resource efficiency in terms of time, in terms of people. It is cost effective from the start, particularly for SMEs. Why do I say that? Is because if you look at the building, the basic simulation model, if you're an SME, you don't have to do everything. You can just concentrate on the process, be it virtual training of the simulator, be it the basic simulation design of input outputs. Just focus on those parts which you need and create the digital twin for that use case. And it designs a digital future that is scalable, flexible, and accessible. Scalable, sky's the limit. You can start with a use case today. With the example I spoke about the Gigafactory, they're scaling up the production very, very quickly. So they can start with one and just continuously add on the various production sites. And if you look at the factory from Germany, which I explained earlier, it was a brownfield. It's not even a greenfield site, it's a brownfield. It's an existing setup with no possibility of changing the space, adding the space. You have to work with the space you have. And we managed to also make that fully optimized and make it fully automated by using the digital twin. So that was it for my introduction to this digital twin, and hope that gave you some inspiration to use this. Thank you.
Thank you, Mr. Mahadevan, showing how fusion of digital twins, robots,